Question 3. Write an equation including state symbols, so that's S for solid, L for liquid, G for gas, AQ for aqueous or dissolved in water, for the reaction with the enthalpy change equal to the standard enthalpy of formation of CF3 gas. So standard enthalpy of formation is where you make 1 mole of a substance from the elements in their standard states. The standard states is how you'd normally find them in a lab under laboratory conditions of temperature and pressure. So we're making 1 mole of CF4. What will we make it from? We'll make it from carbon and fluorine. Carbon, C, is a solid, and fluorine is F2. We're going to need 2 moles of F2, and that's a yellow gas. Explain why CF4 has a bond angle of 109.5. Well, carbon's in group 4, so it has 4 electrons in its outer shell. If 4 Fs come and bond with covalent bonds, those 4 electrons, carbon's going to have 4 bonding pairs, and it's got no leftover electrons, so it's going to have no lone pairs. It's got 4 bonding pairs. These will repel equally and as far apart as possible and form a bond angle of 109.5. It'll form a tetrahedral shape. So around carbon there's 4 bonding pairs of electrons. These repel equally and spread as far apart as possible. You don't even need to mention it's in a tetrahedral shape. We've got some standard enthalpies of formation here of each of these chemicals, but we haven't got C2H6, and it's asking us to work that out. So what you need to know is that the enthalpy change, the overall enthalpy change, which is given here, delta H, is minus 2889. That equals the enthalpies of the products, so 2CF4 and 6HF, those two added together on the right hand side, subtract the enthalpies of formation of these two, so 1 C2H6 and 7 F2. We don't know the C2H6, it's not given to us, so that's what we've got to work out. So minus 2889 equals 2 CF4, so that's 2 multiplied by 680 minus 680, 6HF minus 269 multiplied by 6. Take away the enthalpies of formation of the reactants, those on the left hand side. 7F2, F2 is 0 because it's an element, it's already as an element, so there's nothing to form there, so that's 0. Take away the enthalpy of formation of C2H6, which we haven't got, so we'll call that X. So we take away 7 zeros, which we can leave out, take away X, which is going to be the value of the enthalpy of formation of C2H6. The easiest way of doing this is minus X, take that across to the other side, it becomes plus X, minus 2889, take this across to the left hand side, it becomes plus 2889, so X equals plus 2889, take away 2 times minus 680, which is minus 360. 6 times minus 269 is 1614. It equals, X equals minus 85. And it's in kilojoules per mole, because the other values are in kilojoules per mole as well. Methane reacts violently with fluorine according to this equation. Some mean bond enthalpies. Now bond enthalpy is slightly different. I always think BERP, B-E-R-P, BERP. Bond enthalpy is reactants take away products. It's the other way around really from enthalpy. Reactants take away products. So we add up all the bond enthalpies of the reactants and we then subtract the enthalpy of the bond enthalpies of the products, and that equals the overall bond enthalpy, which is my delta H. So let's have a look. The bonds broken, i.e. the left hand side, the reactants, I've got CH4, I've got 4 lots of CH in CH4, so I've got 4 lots of CH. I've got 4 lots of FF or F2. Okay, so that equals 4 times 412 plus 4 times F2. I've not been given F2, that's what I've got to work out. The bonds form, so on the right hand side, 4 CFs, 4 HFs, so that's 4 times 484, which is a CF, and 4 times 562, which is a HF. And remember what I said, bond enthalpy, or delta H minus 1904, equals the bonds broken, or the reactants, burp, bond enthalpy, reactants, takeaway products, reactants or bonds broken here is this value, 4 times 414 plus 4 times F2F that we don't know. Take away the products or the bonds formed, minus take away 4 times 484 and 4 times 562. So when we rearrange it, 4 lots of F2F, okay, equals minus 194. Take away 4 times 19412 because I've taken it to the other side, so it's gone from plus to minus. And then the minus values here become plus on the other side, so they go plus equals, and all of that equals 632. So FF is 632 divided by 4, so 4 of them equals 632. So one of them is 632 divided by 4, 158. Is the student correct? The student suggests that one reason for high reactivity of fluorine is a weak F2F bond. Is the student correct? Justify your answer with calculation. The student's correct because the FF bond is much less than the CH or the other covalent bonds. Therefore, the FF bond is easily broken. 158 seems to be much less than the other bond enthalpies in the question.